we are ready for part G according to my page, right?
Yes.
So picking back up in 6.4. And I still have the previous page, so we can, and all my markings and stuff, BenQ saved for me. So on G, we are doing the integral from -8 to 13 of f of x dx. And if you recall, integral, we're doing area under the curve. So what do we know?
We all know that first one just like that,
I would say, I'm guessing.
right?
So -8 to 13. Well, I will say right here on B, I see 0 to 13. Could we use that answer? I don't know if that's what I did here. I don't think that's necessarily what I did.
I think we could
But-
do 0 to 13 and 0 to 6. And then just add the other two, right?
You mean the -6 to 0?
Oh, yeah.
Okay. Yeah, okay. So we need -8 to 13. So the key that we don't know is
-8 to -6.
-8 to -6. So let's figure that out. So -8 to -6 looks like a triangle. So that triangle is going to be 1/2 base height. So that triangle is going to be 4, yes? So if we're going -8 to 13, you can do 4. And then what? We're going to have to, what are we doing with 9/2 pi? Subtracting 9/2 pi. And then if I'm just looking at my picture here,
Adding 20.
we can add 20 and then
Subtract 13.
subtract 13.5. Yes? Or we'd already done 20 minus 13.5 and got 6.5. So however you want to do this. So it looks like in my notes I have 4 minus 9/2 pi plus 20 minus 13.5. So different ways we can, let's see. I already know 20 minus 13.5 was 6.5. My gosh.
Add the 4.
So 4 plus 6.5 is going to be
10.5.
10.5. So one option is 10.5 minus 9 pi over 2 or 9/2 pi. Now, with that in mind, I'm going to move that pi to the top. I don't foresee that being a multiple choice answer
I don't either.
because
There's a
there's a decimal and a fraction. So 10.5. What do you know about 10.5? Well, my brain would say 10 and 1/2, but make that improper, and that is 2 times 10, 20 plus 1. So that's 21/2 minus 9 pi over 2. What if we go one more step?
21 minus 9 pi over 2.
Okay, common denominator of 2. So on top you can say 21 minus 9 pi all over 2. Now, am I saying you have to do that for an open-ended problem or something? No. But I'm just saying I don't see 10.5 minus 9 pi over 2 being an answer for multiple choice. So be able to make those connections, right? Okay. Changing. H. F prime of -6. Let me go back to my picture. F prime at -6.
-2.
I cannot. I don't know
-2.
what we did to get there, to figure that out. How do we figure that out?
F prime is the derivative. The derivative is the slope. And that is
Yeah, you're right.
-2 over 1. So it's
From the end point to 6?
No, just -6. At -6, what's the slope? Oh, I was doing 6.
No,
That's
there's
still the same thing.
I was like, there's a cusp, a sharp point.
Oh, I was doing at +6.
I wondered why you were so confident there.
Yeah. I was thinking the wrong thing.
Okay. So F prime is derivative. Derivative is slope of the tangent line. At -6, we have a hard corner, a cusp, a corner, I don't know what you want to call it, but not a smooth curve. So with that in mind, D and E. Where's Kylie when we need her, right? Does not exist or undefined because there is a cusp. Okay. F double prime of 6.
What? F prime of 6 is what? 2? -2?
No, it's double.
I know. I just.
She's just
said
working
F
there.
prime.
Okay, so when we look right here, right, that's where we're looking. There's 6, right?
Yes.
So if we work through our pieces there, which is, so f of 6, what's just f of 6 in general? 2, right? That's the value. Then if we talk about first derivative, f prime of 6 is what?
-2.
-2, because that is the slope. That's what Doug was trying to do on the last part, right? F double prime talks about concavity, yes? I'm trying to think why I don't have a better answer in my book, but do we have any concavity happening here? Okay, it's a line, right? And so if the first derivative is a slope, and if it's already a straight line, what's second derivative going to be? What? Think about it this way. If we look at what this equation is, that is what? I don't know. It would have a slope, right? So the original graph, yeah, it would be -2x plus some number, wherever this ends up crossing up here, right? So if you think this way, okay, so f of x at that point is 2x plus, I don't know, some number that I don't care about. Fair enough? Oops, excuse me, -2x. This is a negative slope. So then the first derivative is -2. And so what's that make the second derivative?
0.
That makes it 0. Okay? And of course, those are all happening at 6. Okay? Okay. J. Average rate of change. Says it right there in front of you. So Hannah says AROC. How do we set up AROC?
F of B minus F of A over B minus A.
Okay. So f of b minus f of a is going to be f of 5 minus f of 0 over b minus a is going to be 5 minus 0. So I'm going back to my other screen. F of 5 is going to be 4. F of 0 is 0. Yes? So 4 minus 0 over 5 minus 0, which is 4/5. So you do remember some stuff from first semester. Okay, true or false? And this is leading us into our properties. The integral from 0 to 2 of f of x dx plus the integral from 2 to 4 of f of x dx equals the integral from 0 to 4 of f of x dx.
Yes,
Why?
because it's just what we did at G. It's the same thing, I think.
Because it's from 0 to 2 to 4.
And then
So
that's from 0 to 4.
0 to 4.
Okay, so logically it makes sense.
Mm-hmm.
If you're going from 0 to 2 and then 2 to 4, you put them together because that 2 overlaps, right? Because this is a property that we're going to talk about. Because that 2 overlaps, then yes, this checks. Now, prove it. What is the integral from 0 to 2?
4. Yeah.
Is it?
Yeah.
From 0 to 2.
I don't say we haven't even done that one technically. Okay, so that's going to be 4.
And then 2
2 to 4 is going to be 8. And then what's 0 to 4?
12.
And honestly, I would look on my screen at this piece is going to be the 20, take away the 8, which is 12. Whoops, wrong way. So logically it makes sense, yes? So 4 plus 8 does indeed equal 12, and it is true, okay? Important property to know. Okay. Over which values of x is f of x not differentiable?
Negative 6.
That much is not double differential.
So if it's not differentiable, what's that mean? What are places we can't take the derivative?
Negative 6.
Negative 6.
Why negative 6?
Cusp.
Okay, that hard point, yes? So negative 6,
0.
the 0 ends up being
Cusp.
a cusp, a hard point. What else?
Negative 7.
I have to look at a paper without all the... Oh, 7 does change a little bit, doesn't it? Okay. Sorry, it's hard to tell on this, but there are 2 different slopes going on here. So 7.
Is it like 2 and 5 and 8 and 11?
Are all those included? Yes?
Yeah.
Those are all hard points. It doesn't just have to be points on the x-axis. Okay? And then I do not have endpoints included here. Just, we don't really know what's going on at the endpoint. So I have at x equals negative 6, 0. I think we listed all of these. 2, 5, 7, 8, and 11. We listed all those, didn't we?
Yep.
Yeah.
Okay. I see. Those are just the ones I have listed in my answer key. Okay, guys. That takes us to properties. Several of these properties are going to be old news at this point, just based on everything we've talked about. Okay? The definition of the definite integral of f on the interval a to b specifies that a must be less than b. Okay, so your lower integral is less than b. Now, however, it is convenient to extend the definition to cover cases in which a equals b or a is greater than b. So, if a equals b, integral 1, we've talked about this. If f is defined at x equals a and the integral from a to a, that's going to be 0 because you're going the integral from a number to a number. There's no area under the curve, okay? So that's 0. So that's just a rule to know. 2, assuming f is integrable on a to b, then the integral of, so again, remember, a is assumed to be smaller than b if you have your numbers upside down, essentially. We've talked about this already, haven't we? It's a negative. So you flip your bounds and you put a negative out front. We just talked about 3, didn't we? This was our true or false question. If f is integrable on the 3 closed intervals determined by a, b, and c, then, so the integral from a to b is equal to the integral from a to c plus c to b. So if these middle numbers are matching, then it's going to be integrable from the smallest to the largest piece there. Let's see. Haven't talked about these as much here, but they're all things we know. So if k is a constant, so if you have an integral from a to b and you have a constant times a function, an option here that is helpful at times is you can just pull the constant out front. Okay? Same thing is true here. Oh, wait, no, this is something else, sorry. Then the integral from a to b of k, well, when you integrate, we add a variable on there. So a shortcut here is if k is just a constant. Remember, k is a constant. And you're doing this integral from a to b, you can shortcut that and do the constant times b minus a. Okay? I will learn more later about why that works and why it makes sense, but it makes perfect sense in the world of integrals. And then 6 should make sense to you. The integral from a to b of f of x, and then either add or subtract g of x. We've been breaking them into pieces, haven't we? We haven't been writing it out like that, but then the integral of a to b of f plus or minus the integral of a to b of g. So the idea that we can add and subtract all those pieces. Okay? Now, putting this in writing is important when we come down to example 2. Okay, we're not looking at a picture this time. We're looking at given integrals. So use the properties to evaluate each of the following. So we're given that the integral of f from a to b is equal to 8. The integral of g from a to b is equal to negative 3. And the integral of h from a to b is equal to 5 halves. So we're going to use our properties here. So a, the integral from b to a of g of x dx.
3.
Why?
Because it's the negative.
Yeah.
A to B.
This right here is the negative of the integral from a to b. So switch those bounds around, right? We're given up here the integral from a to b, not b to a. So to make it match, we switch them, and there's a negative applied when we do that. So that means this is going to be the negative of negative 3, which is positive 3. Okay, b. The integral from a to b of 2 times f of x dx.
2 the integral a to b.
So officially, you can take that constant, put it out front. So 2 times the integral of a to b of f of x dx, which means we're going to be doing what?
F of x. A to B.
2 times 8.
Just 8, which is 16.
2 times 8, which is 16. Okay, c. The integral from a to b of 5 dx.
That's 0.
Huh?
That'd be 0.
No.
5.
There's a rule up above. This is the integral of a constant.
K in the parentheses b minus a. So, well, we don't know what b and a are.
So 5 B minus A.
5 b minus a.
5 times b minus a. 5 times the quantity b minus a, I should say. I assume you guys had parentheses as you wrote it. Okay, so that's just because 5 is a constant. And again, we'll learn how to evaluate definite integrals before long. And that rule, you won't need that rule. It'll make sense. Okay? D, the integral from a to b of 5 plus g of x dx.
Moving to the integral
Integral
of
from
5.
a to b 5 dx plus the integral a to b.
Okay, so
Yeah.
start it with the idea that there's 2 things being added, so we can break it up into the integral from a to b of 5 dx plus the integral from a to b of g of x dx, right? So if there's adding within an integral, it can be broken into pieces. What about the integral from a to b of 5 dx?
5 B minus A.
5 times the quantity, b minus a, plus what about the integral from a to b of g of x dx?
Negative 3.
Negative 3. So I said plus 3, but I really should say, oh well, I'm just going to leave it as plus negative 3. Obviously, it's minus 3. Okay? So does that make E pretty easy then?
Yeah.
The integral from a to b of f of x minus h of x dx. So if we're getting official, first of all, it's the integral from a to b of f of x dx minus the integral from a to b of h of x dx. What information do we know?
F of x is 8, h of x is 5 over 2.
9 halves.
8 minus 5 halves. Should I leave it as 8 minus 5 halves?
No, 9 halves.
Should we trust Doug's answer?
Yeah.
Nope.
What?
So what is 8 with a denominator of 2?
16 halves.
So what's 16 halves minus 5 halves?
I did 15 minus 6. I'm an idiot.
Okay.
My math is not.
As I said, should we trust Doug's answer? As I'm up here shaking my head saying no. Doug messed up his math.
My math is not math.
Nope, it's not.
Too cool for that.
Okay.
I'm having a brain freeze.
F. The integral from a to 4 of h of x dx plus the integral from 4 to b of h of x dx.
5 over 2.
What? There's no b.
It's 0.
Yeah, there is.
Well, if they're
Oh,
adding
yeah.
it in there, yeah, they're going to equal the same spot, so it's 0.
But it'd be it's a to 4 and 4 to b, so it'd be a to b.
Okay.
Which is
So
0.
this is our property here where because the upper limit here and the lower limit here match, we can take these two integrals that are being added and write it as one integral because this 4 matches. So they're both h's. We can say this is just overall the integral from a to b of h of x dx. Okay, so this is our property. This is this property right here. Okay, 4 is our c value. Okay, I'm thinking maybe you were trying to use the 4s as your limits.
Because it made sense. But I guess it's not.
Yeah, the 4s match, and so the 4s, the ones that match are the ones that are out, and we have the a and b. And the integral from a to b of h of x dx is 5 halves. Okay? Okay. Ready for the next one? Example 3. Find the following. If the integral from 1 to 5 of 3 times f of x plus 4 dx equals 34, find the integral from 1 to 5 of f of x dx. Think algebra here. Think a big old equation.
Parentheses first.
Okay? So I'm going to suggest we take that left side and break it up into all the pieces we can. Okay? So 3 times f of x plus 4, since there's a plus sign, we can rewrite it as two integrals being added, yes? And this constant of 3,
Multiplied out in front.
it can go out front of the 1 integral, yes? So what I'm going to rewrite for right now is 3 times the integral from 1 to 5 of f of x dx plus the integral from 1 to 5 of 4 dx. And that's going to equal 34. Are you there? Before I go any farther, I want to make sure we're all there. That was just me using what, like 3 different properties at once. So, okay. What can we do now?
4 times 5 minus 1.
Okay, that second integral, the integral from 1 to 5 of 4 dx. Can we evaluate that? This integral right here, because it's a constant, remember it's the constant times, it's k times b minus a, and b minus a is the 5 minus 1. So 4 times 5 minus 1 is 16. So if I carry down what I had from the first piece, it was 3 times the integral from 1 to 5 of f of x dx. Now I have plus 16 equals 34. If you see it, our job, remember, is to solve for The integral from 1 to 5 of f of x dx.
That's 16 divided by
It's algebra here, yes? Okay, so we're going to subtract 16. And so then I'm going to have 3 times the integral from 1 to 5 of f of x dx. What did you decide 34 minus 16 was? 18?
Yes, I redeemed myself.
I didn't check you.
Oh.
Are we agreeing?
Sure.
I mean, it divides by 3, so that makes sense. It is. Okay. And then you can divide by 3, yes?
Which is 6.
So we have the integral from 1 to 5 of f of x dx is equal to 6.
It's so crazy.
Okay? I like those problems. If you can see them, they're fun.
They are. That was-
Okay? If you can see.
I would do these
Otherwise,
in
they're a frustration, I'm sure.
I can't
It's just,
see it.
it's just easy.
Yeah, and that's why you saw the algebra behind it, right?
Okay.
Okay. Even and odd functions. I don't know how much you remember about even and odd functions. We learned them back in pre-calc.
It'd bring up-
We've talked about them on and off since, here and there a little bit. So, even and odd functions. Consider if f of x is an even function. Now, think about this. Even. Do you remember what it meant to be even?
No. Remember talking about it?
Because if you remember what this means, it makes perfect sense.
Across the y-axis.
Symmetric across the y-axis. Okay? That's important to know moving forward. So, what they're saying here, symmetric across the y, that means what? The left of my graph looks the same as the
Right.
right of my graph, yes? If we're talking an integral and we're talking area under the curve, and the left and the right are the same,
This is double.
okay, so this is saying where the integral from 0 to 3 of f of x dx equals 8, then what is the value of negative 3 to 3 of f of x dx?
Oh, okay.
And it's going to double it because the idea is, I just have a random picture here. Do I know what this graph looks like? No. But the idea is, if here's negative 3 and here's 3, if 0 to 3 is 8, what's this have to be? 8, because this graph is symmetric across the y-axis. Okay? I'm not saying I knew this is a parabola. I just know parabolas can be symmetric across the y-axis if positioned properly. So the idea from 0 to 3 is 8. Then we also know the integral from negative 3 to 0 is 8. And so, yes, 8 plus 8 is going to be 16. Or however you want to explain that to yourself. Okay? So that's kind of goes with our properties. Good to understand. Odd function. Nope.
They're not symmetric.
No origin.
Okay, odd function is symmetric across the origin. Okay, it has that kind of that diagonal symmetry. And so, where the integral from 0 to 3 of f of x dx equals 8, then what is the value of negative 3 to 3 of f of x dx? Let's do a cubic graph. That's symmetric across the origin, because symmetric across the origin. Officially, let's see. I've taught it as you can reflect it across both axes. If you can reflect this like across the x and across the y, what's in the first quadrant will land on the third quadrant, right? It can also, I've decided, be called a rotation of 180. Okay, but here's the deal. As we look at this, so if 0 to 3, I'm going to say 3 is right there. If that's 8, What's 0 to negative 3?
Negative.
2 equals 0.
Okay, because it's 8, they're both 8s. The areas are both 8s, but because the one's below the x-axis, it is a negative 8. And so you do end up with 8 plus negative 8, which is 0. So the idea here, the integral from negative 3 to 0 of f of x dx would be equal to negative 8. And 8 plus negative 8 would be 0. Okay? Those facts are good to know, good to understand, right? Okay. And we're ready to do some area. It's all about area by hand today, pretty much. In some cases, a definite integral can be evaluated by using geometry. What we're doing today, because we don't know how to evaluate integrals yet, sketch the region by the definite integral and evaluate each integral using a geometric formula. So we're doing area under the curve. Okay, I'll be honest. A, once we know how to actually do an integral, this would be pretty easy to do as an actual integral. B, that's not easy to integrate. Okay, that's better to do geometry with. We're going to do these all geometry today because that's all we know at this point. So, we're doing the integral from 1 to 4 of x plus 3 dx. So, what do we need to look at the picture of? What is x plus 3? What are we trying to graph?
A line.
You're thinking about the line, y equals x plus 3. And specifically, we're concerned about the piece that goes from 1 to 4. Okay, so here's my graph. So let's see. We know at 3 there's going to be a y-intercept. And then what? A slope of 1. So you're going to rise 1, run 1. Okay, there's my line, y equals x plus 3. Basically, I went up 1 over 1. I get kind of specific with my points because I'm going to need to be able to find some information here, aren't I? So I had a point at 0, 3, 1, 4, 2, 5, 3, 6, and 4, 7 is how mine ended up looking. Now, if we're doing the integral from 1 to 4, what's that mean? The area under the curve from 1 to 4. Wow, that was really curvy. What do we have here? Got a trapezoid? Unless you prefer a rectangle and a triangle, whatever floats your boat. I personally would say trapezoid though. So, area of a trapezoid, what do I need? Okay, base 1, base 2, and height. So, it's 1/2. What's the height?
4,
3.
3.
The distance from 1 to 4, the height between the two parallel bases is 3. Base 1 plus base 2.
4.
What are those individual bases?
7.
Okay. On the left, it's going to be a 4. On the right, it's going to be a 7. So 4 plus 7. Do you see the reason I drew a very specific graph? The more details you put in your graph, the easier this is at this point. So, half of 33 in my brain is 33 halves. And that's what I have in my answer key. it's not unusual to see somewhere on the AP multiple choice them to throw an integral at you that can't be integrated by hand. Like if you're on a non-calculator section, throw an integral at you that can't be integrated by hand, because I'll be honest, once we start integrating these like algebraically, like how we do derivatives and stuff, you forget you can do this geometrically. And it's just like, oh, okay, I got it. Piece of cake. Well, then you hit one that you can't integrate by hand, and it's not piece of cake. So you got to remember the geometry portion. For instance, B.
Let's go C.
Let's go C. Nope. Okay, so as you're looking at this saying, oh my lordy, I don't know what this is. Y equals square root of 4 minus x squared. Do you know what that graph is? No?
Well, it's a square root. Is that
Oh,
one
so
that
it'd be
goes?
A square root graph is half of a parabola, half of a sideways parabola. However, this is square root of an x squared.
That's the line.
Nope. So let's rearrange this a little bit. If we square both sides, it's going to be y squared equals 4 minus x squared. If we add the x squared over to the other side, this is x squared plus y squared equals 4. This is where your math teacher for the last couple of years might have failed you and you might not recognize what this is. This is where I need you to recognize what it is, but I don't know if you're going to succeed here.
A triangle.
No?
Is that a hyperbola? Or
With an ellipse.
It's a version of an ellipse. A very specific version of an ellipse.
Circle. Oh.
This is a circle with
Radius of 4.
radius of 2.
Radius of 2.
Because that's you take the square root.
This is of the form x squared plus y squared equals r squared. Again, as I said, we haven't done as much with circles as we probably should have. I need to find a way to put it better in the curriculum. Okay, that's one to recognize, folks. I cannot express that enough. That is one to recognize. So, now, we are looking at a circle with radius 2. Okay, let's think about this graph here. A circle with radius 2. Where are we looking from?
Negative 2.
-2
I need a full
to 2.
circle.
No. So Doug's question, and this is a good question to address, he says, so it's the full circle then, right? And I'm going to say no. Because when we started this, we only had y equals the positive square root of 4 minus x squared.
So it's half a circle.
So this, because it's only the positive, is the top half of the circle. Okay? Are you following me? This is a tricky one. What would if we had the bottom half, there would have had to have been a negative. Y equals negative square root of 4 minus x squared. Are you following? Maybe you couldn't have gotten there on your own, but are you following? Okay, so we need the area from -2 to 2 of the square root of 4 minus x squared. Statement or question?
Question.
Okay.
We said plus or minus. Would that be the full circle? Would that be the full circle?
And I don't know that you'd see plus or minus in an integral setting, but yes. I mean, this right here, x squared plus y squared equals 4, is the full circle. But that's not what we were given. That was me trying to show you what this is a form of. Really, this is the idea that you would have started here and you would have gone back. You would have solved for y and gone back to there. Okay?
Pi r squared. 2 pi r. Pi r squared. 2 pi r squared.
Pi r squared is area of a circle.
Half pi r squared.
We're doing the top half of the circle. What's my radius? 2.
2 pi.
Yeah.
It would be the same if your radius is 2. Okay?
I think she's making that for me.
Oh, yes. Yes. Okay. Yeah. So, you see the square root of a number minus x squared, folks. Your brain's got to go and think circle. Okay? So, if this had been the square root of 9 minus x squared, we'd be talking a circle with radius 3. Square root of 25 minus x squared, we'd be talking a circle with radius 5. And these are circles centered at 0, 0, which makes the math easy. Okay? Okay. Okay, let's work those brains.
Ooh, sweet, absolute value.
Yes.
The integral from -2 to 4 of the absolute value of x plus 3.
So that's a d translated up 3 units.
Yes? Okay, so I need a pretty specific graph here. So I'm going to have a v translated up 3 units. And what do we know about the sides of those v's? They have slopes of 1 in this case, right? So should have put my dots in afterward, I guess. I'm laughing at the right side of my V, which is not a very straight line, because it's hard to read on the big Q sometimes. You don't understand it fully until you work on the big Q, but
It's original paper sometimes.
I have a hard time graphing the big Q at times. Okay. On the left, I put my dots going out to -2. On the right, I put my dots going out to 4. I had a reason for that, didn't I?
Ask for -2.
Okay, so we're looking at the area from -2 to 4. So are you seeing where we're going here?
Yep.
So we need this area, all of that. So what are you seeing?
2 trapezoids.
2 trapezoids? Okay. I'm going to do T1 and T2. What's the area? How do I do the area of the first trapezoid?
The
5.
Well.
Yeah.
And then that's in parentheses plus 3 times 2.
Okay, so 1/2. The distance between your bases is 2, and then bases are 5 and 3. So that first trapezoid is going to be 8. Second trapezoid?
7 times 4.
1/2. This time we have a height of 4, bases of 7 and 3. So 2 times 10, 20. And put it all together, and we're at 28. Oh, shnikes. Okay, we're going to do D. I'm running out of time. So, D is important. Good concept here. The cube root, or the integral from -4 to 4 of the cube root of x dx. What's a cube root graph look like?
Is it sideways cubed?
Sideways cubed. Ask the Algebra 2 students. They should be able to tell you, because I taught on that Friday and today. Okay? Should. So sideways cubed, there's your cube root graph. Approximate sketch. We're going from -4 to +4.
0.
I agree with that.
Because it's positive. So cancel.
Because this graph is symmetric about the origin. This is an odd function.
That's all.
This piece right here is going to be a positive area. This piece right here is going to be the equivalent negative area. Do I need to know what those pieces are?
Nope.
No. I know it equals 0. I don't have to know I don't have to do any more specific math than that. Okay? And I'm just going to say down here, because y equals the cube root of x is symmetric about the origin. I'm going to say symmetric about the origin because do you guys remember what odd means? You might now, right?
It's just odd. It's really odd.
Okay. E.
That's why.
E is a lot like A from the front side, I think.
Yep.
So I'm going to tell you the answer for E. Huh? We get out at 15, right?
Yeah.
Which is like 3 minutes, and I'd more rather talk about F,
Oh, okay. Sorry.
right?
Yes.
Yeah.
So 4 minutes, whatever. E is just going to be, I mean, you're doing 3x plus 2. It's a different slope, but it's not going to be a big old another trapezoid. Okay? F. That looks a little interesting, doesn't it? Okay, the integral from 0 to 2 of 1 plus the square root dx plus the integral from 5 to 2 of 3 minus x.
So
So we got a
a
semicircle
You see a semicircle in there.
and a line.
Huh?
Would that other one be a line? The 3 minus x.
You could think of it as a line. Now, what's going on? You see this semicircle here, but you also have a 1.
So up
So
one.
it translates.
You could think of it, okay, so we can go 2 different directions here. I'm following. We could think up 1, and then that's just going to put like a rectangular block underneath it, isn't it? Okay, I'm good with that. I also was going to say we could break this into 2. I'm not saying you guys are wrong. Maybe you guys don't like what I'm getting ready to do. I'm saying we could say this is the integral from 0 to 2 of 1 dx plus the integral from 0 to 2 of square root of 4 minus x squared. Are you seeing where I'm going with this as an option?
Oh, so then it would just be 1
Yeah. And then
times.
this one, I think I actually, because I was in the habit of breaking, I actually broke this one up too. So the integral from 2 to 5 of 3 dx minus the integral from 2 to 5 of x dx. I'm not saying that second one had to break up. Technically, the first one, did it have to break up? Not necessarily. You guys were seeing it. Now, the first one, the integral of 1, that's the integral of a constant. So it's 1 times b minus a. So 1 times 2 minus 0, or in other words, 2. Now, you guys called this a semicircle. Notice it's from 0 to 2.
So it's a quarter circle.
So it's actually going to be a quarter circle. Do you see that? Because it's just from 0 to 2, and it's just the positive square root.
That'd be 5.
So that's going to be 1/4 pi r squared. Are you with me on that? So that's going to be pi. We have the 2 there. We have the pi. This one, you can do a constant here if we broke it up like I did. So it's 3 times 5 minus 2. So that's a 9. And then we have the integral from 2 to 5. You would end up having to think about the line. Okay? You end up with a trapezoid. It's 21 halves. Okay? So this would be, you would have to figure that out. Okay? So you end up with the trapezoid here, and I ran out of time. So if we clean this up, 2 plus 9 is 11. So what? 11 minus 21 halves is 11 and a half plus pi. So you end up with
23 plus 5.
no, 11 minus 11 and a half.
Oh, 11 minus 11 and a half.
Wait. 11. 21 halves. No, that's 10 and a half.
10.
There we go. I'm like, something's not mathing. So 11 minus 10 and a half is a half plus pi. You would leave your answer like that. Okay? Not like terms. You can't add them.
Okay.
You guys were still stuck. I heard a pi over 2. I didn't address it, but not like terms. Okay. We got all but one done. The one we got done, we didn't do as a trapezoid. So, and you got the gist of this one, even though I didn't get to that last piece. Okay? Homework. Work through the integrals. Okay, and then I would encourage you to look at that quiz review worksheet, see where you're at on it. Make sure you can still find it in your stuff. Okay? And I think 6-4 answer key is out there, but I'll have to double check.